All right, we're going to keep going with the SI sheet for April 29th to May 3rd with problem number 7. It says give the final product of the reaction below. You are reacting an aldehyde with a secondary amine, so you're going to form, let me write this down, an enamine product. And so typically an enamine has a carbon bound to a nitrogen with an adjacent double bond. And so you can literally go through these answer choices, and if you know that a secondary amine is going to add to an aldehyde to form an enamine, you can eliminate answer choice A because there's not an adjacent double bond. You can eliminate choice C because that's an imine product, kind of, where the nitrogen would be double bonded to the carbon from the carbonyl compound, so you can eliminate C. There's no double bond in D, so you can eliminate it, and answer choice E is kind of the wrong direction, and it's not adjacent to the carbon nitrogen bond. And so, well, I mean, I guess it is, but it's the wrong direction. So we'll leave B for now, but we'll work out the reaction. And you'll see that the product that we're going to form, you're going to replace the oxygen with the nitrogen, with the amine group. And then to stabilize, I mean, it's going to involve some positive charges, and then to stabilize it, you'll form the carbon double bond adjacent to the carbon nitrogen bond, and that carbon double bond forms on the aldehyde side of this product, not on the nitrogen side. So the answer choice is B. The reaction mechanism for that is in the notes. I think it's important to look at, but it is a pretty systematic reaction. You know, primary amines are going to add to that aldehyde to form an imine, and secondary amines are going to form the enamine, and they're pretty standard. Maybe one of the easier reactions to look at product recognition for, but I don't think that product recognition is going to help you on a test. So anyway, check out that reaction mechanism, and then see if you can finish it to the answer choice B. Moving on to problem number 8, it says select the correct starting materials to form the target compound via a Wittig reaction. So this is kind of a retrosynthetic look at a Wittig reaction. And we saw before that a Wittig reaction forms an internal carbon-carbon double bond, where kind of the general reaction is you've got this Wittig reagent where the phosphorus is double bonded to a carbon that has two R groups attached to it, or maybe even an H group, R or H groups. There's something attached there, and then these, and then you've got like a ketone or an aldehyde, a carbonyl group, and you're switching this side for this side. You're kind of doing a switcheroo, and so you end up forming this generic product. And so you can think about in a retrosynthesis problem what carbon-carbon double bonds you're forming. So this compound, the target compound, has two carbon-carbon double bonds that you could be forming. And I've highlighted them with blue and with green. And so if you think about it, if you're forming that bond, then the reagents, you're going to split that bond up, and you can substitute the triphenylphosphine on one side of it and the oxygen on the other side of that double bond, because you know you're just switching them out for each other. And so with product A, let me kind of scroll down and get some room so you can see what I did here. So I split that to form, I split that blue bond right there, and I formed these two blue products, where I could have put the PH3 on this side or on this side, and then the O on the opposite side. So these are the, you could have this set of reagents or this set of reagents. So 1 and 2, if you split up this carbon-carbon double bond that I've highlighted in blue. Likewise, you could split up the carbon-carbon double bond that I've highlighted in green and do the same thing. Just substitute the triphenylphosphine on one side and the oxygen on the other side. And you can form these two reagents, 3 and 4. And so all you do is you see which reagents line up with with one of these 4 options. And if you look at D, D is going to be our product number 2 right here. And you can see that that lines up perfectly. And so we know that you can form the target compound out of these 2 reagents, and that answer choice is D right there. So that is number 8. I'm going to move up, sorry for dragging you through all those problems, but with number 9, number 9 is also kind of a synthesis problem involving a Wittig reaction. And this is more of a big picture problem. It's harder to kind of give the exact way that I thought about this. It's not as linear. I just kind of had to study the problem on a whole. So I'm going to walk you through my thought process here. It says, give the alkyl halide A and the reagents B and C for the following reaction sequence. Note the reagents B and C can have more than one compound. And so I'm starting with an alkyl halide, and I can kind of tell with the PPH3, that's kind of like a buzzword type thing for me, that I'm doing a Wittig reaction. And so I can look here, and I know that I'm forming one of these 3 double bonds. And so if I look more closely at this compound right here in the middle, I know that that's a ylide. I know I'm not pronouncing that right, but a YLIDE. And so I know that it has a resonance structure like this, where the electrons from that carbon move in and form a double bond between the carbon and the phosphorus, eliminating both the negative and positive charges. And that reagent right here is the basis for my Wittig reagent. So if I look at the product, I can see that I've got, if I look at the reagent, I can see that I have this double bond right here and this double bond right here. And that really lines up perfectly with this double bond. I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and it just lines up perfectly. So I'm going to think about splitting up that reagent right there. So if I have this side as my like Wittig component of this reaction, that means that this side over here, let me highlight it kind of in green, is going to be the ketone side, or the aldehyde side. It's going to be the carbonyl side. So so I can draw it right here, CH3, CH3. So I know that if I react these 2 reagents together, it's going to give me this product. And so I know that C right here, what I'm reacting this Wittig reagent with, product C, is this reagent right here. So that's C. So now if I go back to B, I'm thinking about how I formed this Wittig reagent in the first place. And so I think it was, let me see exactly which problem really resembles this, but yeah, it's problem number 2. If you go back and look at problem number 2, it might help you out, because you're kind of doing the retrosynthesis of how you form the Wittig reagent in the first place, and problem number 2 is a Wittig reagent synthesis problem. So I can look at, I just kind of had to honestly just study this problem a little bit and see that the alkyl halide, if I have a bromine that looks like this, and B, if I make B that PH3P with the double bonds, then I know that I can form, I know that these electrons right here will do an SN2 reaction with the bromine, and kick them off and form this product right here. And you can think about that with this double bond. That's the double bond where that bond, it's not a double bond there, it's a double bond in the resonance structure, but that bond is what's being formed there, so you can just work backwards from that point. And so product B then is that PH3P, this is B, and then product A is that alkyl halide that we started with that looks like this. And again, these kind of problems right here, they're hard to give a linear explanation from. You just kind of have to look at it and study it, and as you do more and more Wittig reagent problems, you just kind of notice trends where double bonds are forming, where bonds are forming. So that is my explanation for number 9, and I will see you for the last 3 problems in the next video.